Today we'll take a look at the algebraic basics of linear functions. We'll be looking at the basic algebra behind linear functions. Let's start by considering the following case. We need to travel from our home to the airport in a cab. This cab has a charging system in which the price of the service is calculated based on the distance traveled. As we move from our origin to the destination, we can observe on the meter how the total amount to be paid varies in terms of the distance traveled. That connection is called a relationship. Notice that we can connect the distance traveled with the price of the service. Particularly, we want to recall a special type of relation, which are called functions. Functions take an input value and give exactly one output. In general, we can refer to a function f as a set of ordered pairs consisting of elements of the input set and output set. We call the input set the domain of the function and we denote it by the letter d, where f of x is the rule of the function. Let's see an example. Let's identify the set of ordered pairs that represents the given function f for x, that is 1, 2, and 3, by considering the following options. Let's take each value of x and substitute it into the formula to find the values of y, or f of x. For x equals 1, we have that y, or f of 1, is equal to 2 times 1 plus 1, or 3. This means that the first ordered pair of the function is 1, 3. We repeat the process for the next values. For x equals 2, we have that y, or f of 2, is equal to 2 times 2 plus 1, or 5. When x is 2, the ordered pair is 2, 5. Finally, for x equals 3, we have that y, or f of 3, is equal to 2 times 3 plus 1, or 7. The final ordered pair is 3, 7. So, the correct answer is choice A. Let's practice. In the following exercise, we must identify the set of ordered pairs for the following relation. Notice that options A and B can be directly discarded, since the first components of these sets do not correspond to the values given for x. Then, when substituting the x values into the function's formula, we find the second component for each ordered pair. For x equals 0, we have that f of 0 is equal to 0 minus 2 or negative 2. For x equals 2, we have that f of 2 is equal to 2 minus 2 or 0. For x equals 4, we have that f of 4 is equal to 4 minus 2 or 2. For x equals 6, we have that f of 6 is equal to 6 minus 2 or 4. So the resulting set of ordered pairs means that the correct answer is option C. The general form of a linear function is f of x equals m times x plus b, where m and b are constants. Although it is usual to use f for the function, we can use other letters to denote it, such as g, h, etc. For all linear functions, the starting set and the end set will be all real numbers, unless otherwise stated. Some examples of linear functions are f of x equals 2 times x plus 1, g of x equals 3 times x plus 6, and h of x equals negative x plus 4. Note that for each real value that x can take, the functions above will be defined. Let's consider a real-life example. A certain phone company offers a postpaid data plan in which the cost for the clients is determined by a fixed monthly cost of $3 and by a variable cost of $2 for each gigabyte of data used. Identify the function that models the monthly cost for a client in terms of the monthly internet consumption. The goal of the task is to identify which of the given options represents the cost C of service for a customer. Where x represents the number of gigabytes, GB, of data used, so the function will be denoted by C of x. The cost of $2 multiplied by number of gigabytes of data used will give us the price of internet consumption, so the function C of x must have the variable cost, 2 times x. Then, we include the monthly fixed cost to the formula, which is $3. So, cost function can be described as C of x equals 2x plus 3. Notice that option C is the correct choice. We should note that there are 3 equivalent expressions for linear functions. Considering that y is equal to f of x, we can define the following forms of linear equations: the general form, the slope-intercept form, and the point-intercept form. Note that the slope-intercept form is the linear equation that we obtain directly from the substitution y equals f of x. We can also see that we can arrive at the general form by algebraically manipulating the slope-intercept form. To get to the third form, we must use the geometric properties of the line in the Cartesian plane. For now, let's focus on the first two forms. Let's consider the following example where we must rewrite a linear equation by using algebraic manipulation to obtain the slope-intercept form. Let's apply the properties of equations and of real numbers to rewrite the given equation in the form y equals mx plus b. First, we subtract 4x in both sides of the equation and then simplify like terms. Then, we divide both sides by 3 in order to completely isolate the variable y in the left-hand side. By reducing the fractions and reordering the terms on the right-hand side, we can identify that option B is the slope-intercept form for the given linear equation. Finally, let's briefly recap what we've learned. Linear functions have the form f of x equals mx plus b. The three ways of writing a linear equation are the general form, slope-intercept form, and point-intercept form. I hope you had a good time while learning about linear functions. To go deeper into the subject, we invite you to watch the rest of the videos.